Welcome to the class of sound through slideshow. In this class, I am going to discuss what is sound, how it is produced, what are the properties of the medium, what is the motion of the particle, how the sound wave is created, types of waves, formation and propagation of waves, characteristics of waves. What is sound? It is a form of energy. Sound is a form of energy and it will be produced by a vibrating body. It needs a material medium for its propagation, and ear can detect the sounds of frequency from 20 Hz to 20,000 Hz. Ear can detect the sound waves from frequency 20 Hz to 20,000 Hz, and it cannot detect waves of frequency less than 20 Hz, which are known as infrasonic waves, and waves of frequency greater than 20,000 Hz known as ultrasonic sounds. So, infrasonics are frequencies less than 20 Hz, and the frequencies between 20 Hz and 20,000 Hz are known as audible range, and above 20,000 Hz are known as ultrasonic sounds. Sources of sound and the energy propagation. Source of sound is a vibrating body. The vibrating body produces sound. For example, plucked string, struck bell, vibrating tuning fork, etc. are the examples. Then the energy, it flows from the body, that is from the source, to the ear through the medium. Medium may be air or some other medium. It passes through solids, liquids as well as through gases, so they are called as the medium. What are the properties of the medium that help in the propagation of sound, and what is the form in which the sound travels? The properties of the medium are inertia and elasticity. Inertia and elasticity are the essential properties of a medium for the propagation of sound. Sound travels in the form of compressions and rarefactions. You know, a compression is a region of slightly high density and high pressure, and rarefaction is a region of low density and low pressure. And these two are indicated by the lines shown at the right. In the upper one it is compression, the lower one it is rarefaction. When a wave is passing through a medium, what is the motion undergone by the particles of the medium? The particles of the medium, they execute simple harmonic motion. The simple harmonic motion takes place about a mean position, but that mean position remains constant. It is stationary. The mean position will not be carried, it will not be transmitted, but only the particle vibration will be transmitted. So each particle, it transmits energy to its neighbor, and thereby the displacement will be transmitted. Like this, the energy will be transported in the medium. That propagation of the transmission of the displacement is called as wave motion. How the wave motion takes place? The wave motion takes place in the form of motion of compression and rarefaction. How these compressions and rarefactions are formed in the medium? When a body is vibrated, it creates compressions and rarefactions in the medium air. For example, if a tuning fork is taken, when the tuning fork is vibrated, when the prong moves to the right, then it creates a compression, and by the time it starts from the equilibrium position, goes to the right extreme position and comes back to the equilibrium position, it creates one compression. And when it goes to the left extreme end from equilibrium position, and then it comes back to the equilibrium position, by that time it creates a rarefaction. So a compression followed by a rarefaction will be created by the time it completes one oscillation. These compressions and rarefactions will travel in the medium, and the propagation of these compressions and rarefactions is known as wave motion. What is a progressive wave? What are the types of progressive waves? A progressive wave is a wave which travels in an unending medium and without being reflected back. A wave that passes on without coming back, without being reflected, is known as progressive wave. These progressive waves are classified into two categories, transverse wave and longitudinal wave. The distinction between these two is, in a transverse wave, the motion of the particles takes place perpendicular to the direction of propagation. If the direction of the propagation is indicated by the horizontal line, then the motion of the particle is indicated by the perpendicular arrow, double arrow perpendicular. Then, in the case, that is the case of transverse waves. In the case of longitudinal waves, the propagation, the vibration of the particle takes place parallel to the propagation. Here, the double arrow represents the vibration of the particle. So, the vibration of the particle will be in the direction of propagation of the wave. This is longitudinal wave. So, like this we distinguish transverse and longitudinal waves by the motion, the direction of vibration of the particle. Propagation of progressive waves. Propagation of the waves, the form of propagation of the waves. When we take transverse wave, it will be propagated in the form of crests and troughs. A longitudinal wave will be transmitted in the form of compressions and refractions. So the propagation takes place in the form of compressions and refractions in a longitudinal wave, and in the form of crests and troughs in the form of a transverse wave. And the transverse waves will be noticed on the surface of water. When a stone is dropped on the surface of water, waves will spread on the surface of water. Here we notice the propagation of crests and troughs. So that is the propagation of transverse wave. When we notice the sound waves, the motion of the sound waves, it takes place in the form of compressions and refractions. So this is an example for the propagation of longitudinal wave. What are the characteristics of the wave? The characteristics of the wave are amplitude, represented by capital A, phase phi, period t, frequency nu, wavelength lambda, and intensity I. These six are termed as the characteristics of the wave: amplitude, phase, period, frequency, wavelength, and intensity. These are called the characteristics of the wave. Now I will give you the concept of the different characteristics. First, let us take the amplitude of the wave, represented by capital A. It is the maximum displacement of the particle. The horizontal line represents equilibrium position, and the point above it is extreme position, upward extreme position. The another point in the downward direction is another downward extreme position. So the distance from equilibrium position to either extreme position, either in the upward direction or in the downward direction, each is the amplitude of the wave. So amplitude of the wave means maximum displacement. It may be towards the positive direction or towards the negative direction. Then let us take the concept of phase. What is the concept of phase? First, let us consider the particles to the right of it. Let us name the particles along the curved path as 1, 2, 3, 4, 5. The particle at y displacement is fourth particle. Now, the first particle has come to the equilibrium position and it is going down. When the wave is propagating to the right, the particle will be moving down. The second particle is coming to the equilibrium position, and the third particle is at the maximum displacement and it is coming towards the equilibrium position. The fourth particle is set to move in the upward direction, and the fifth particle is about to start its motion in the positive direction of y-axis. Let us consider the fourth particle. It is at a positive distance y from the equilibrium position, and it is set to move towards the positive direction, extreme position in the positive direction. These two concepts, its position, its displacement from equilibrium position, and the direction in which it is set to move, will be represented by the phase phi. We know that the simple harmonic motion is given by the relation y is equal to a sin phi. Here phi represents the phase of the particle. Depending on the value of this phi, we can determine the position and direction of motion of the particle. In the case of a wave, the equation of a wave is given by y is equal to a sin omega t minus kx. This omega t minus kx gives, it is known as the phase of the wave, and this gives the position of the particle, the direction in which it is set to move. So the phase indicates the position and the direction of motion. What is period? Period is nothing but the time taken. The period is same for all particles, and the period of the wave is same as the period of the particle. Let us consider the period of the particle. The time taken by the particle to travel from equilibrium position to upward extreme position, positive extreme position, and then back to second extreme position, downward direction, and then to equilibrium position. These are indicated with arrows. From equilibrium position to the upper extreme position, that is the motion in the first case, and then from upper extreme position to downward extreme position, that is this motion in the next it takes place, and thereafter it comes to the equilibrium position. The time taken for this motion is known as period of the particle. Period of the particle means the time taken for one oscillation. Then frequency. Frequency is the number of waves crossing a point. Here there is a line at the right, and beyond to the left of it there are waves. These waves, if they are moving to the right, so they will cross that line. The number of waves that cross that line in 1 second is known as the frequency of the wave. The number of oscillations made by the particle in 1 second will be equal to the number of waves crossing through a point in a medium. So this is frequency. What is wavelength of the wave? In the case of a transverse wave, it is the distance between two successive crests, or between two successive troughs, or the distance occupied by a crest and a trough. The phase difference of two particles, if it is 2 pi, then the distance between the two particles will be the wavelength lambda. So we can say it is the distance occupied by a crest and a trough. At the right, I am showing the wavelength lambda in two cases. In the downward figure, you notice that 3 lambda indicates there are 3 waves over the distance. So that red line indicates a distance of 3 lambda. Similarly, in the case of a longitudinal wave, it is the distance occupied by a compression or a rarefaction and a rarefaction. The distance occupied by a compression and a rarefaction will be equal to the wavelength lambda, or the distance between two successive compressions, or the distance between two successive rarefactions. Like this also we can define the wavelength lambda in the case of a longitudinal wave. Intensity. Intensity is defined as the energy flow through unit area of cross section. This cross section should be normal to the direction of propagation, and the energy flow per second is defined as the intensity. Energy flow per second through unit area of cross section which is normal to the direction of propagation is termed as the intensity. To understand this mathematically, consider an area of cross section a tube of area of cross section A, and into this tube some fluid is entering. So E is the energy of the fluid that enters in time t. The energy that enters this cross section A in time t, then the intensity is given by energy E divided by A into t. Like this we can calculate the intensity. Energy flow per second through unit area of cross section and normal to the surface area A. The energy flow should take place normal to the area A, and the energy that enters in 1 second through unit area of cross section is taken as the intensity. What is the relation between speed of the wave, frequency and wavelength? This relation is given by the relation V is equal to nu lambda. V is equal to nu lambda. Sometimes we use n lambda. Here, if the frequency of the source is say nu, let us consider a source of frequency nu. That means it emits nu waves in 1 second. These nu waves that are emitted in 1 second, they spread over a distance v. which is the speed of the wave. So the distance occupied by one wave is lambda. So the distance occupied by new waves will be nu lambda. So V will be equal to nu lambda. Like this we can derive the relation between the frequency, wavelength and the speed of the wave. Summary of this class. Sound is a form of energy and it is produced by a vibrating body. Then it travels in a medium in the form of compressions and refractions. The properties of the medium required for its propagation are inertia and elasticity. The sound waves are longitudinal waves. These are known as progressive waves. There is another type of progressive wave known as transverse wave. In the case of a longitudinal wave, the particles will be vibrating parallel to the direction of propagation. In the case of transverse wave, the particles will vibrate perpendicular to the direction of propagation. And there are the characteristics of the wave are amplitude, phase, period, frequency, wavelength and intensity. Amplitude is maximum displacement. Phase, it gives the position and direction of motion of the particle when the wave is propagated. And period is the time taken for one oscillation, and frequency is the number of oscillations made in 1 second. Wavelength is the distance occupied by a crest and trough or by a compression and refraction in the case of longitudinal wave. And intensity is defined as energy flow rate through unit area of cross section normal to the direction of propagation. When the wave is propagating, the particle will be executing simple harmonic motion about a fixed position. It transmits energy and displacement to its neighbors, and thereby the energy will be propagated in the medium. This is how the motion of the sound takes place. The relation between frequency, wavelength and speed of the sound wave is V is equal to nu